Zero exponent. What does it mean? It means something to the power of 0. It means something to the power of 0. So here we have 0 exponent. So a to the power of 0 is what? Well, let's take a number. A is very difficult to answer. We say 5 to the power of 0 is how much? What should it be? Well, that is the question to be answered. Now here, what we are going to do is, we are trying to use our laws. We'll use multiplying powers with the same base law and dividing powers with the same base. Right? Let me remind you what those were. So multiplying powers with the same base, what was it? So if I have a to the power of m times a to the power of n, what do I get? When we multiply powers with the same base, which is a in this case, what happens to exponents? They get added up. So we get a equals to, this is equals to a to the power of m plus n. And when we divide, that means if I do a to the power of m divided by a to the power of n, then what do we get? We get a to the power of m minus n. Right? Divided, we could also write like this, right? Over a to the power of n. So this gives you a to the power of m minus n. So it gets subtracted. Correct. Now, a to the power of 0. Now that means what? A to the power of 0 means if I put m and n same, then a will be to the power of 0. Does it make sense? I think so. So m minus n is 0 only if m is equal to n. Right, sir. So let's take some examples. So let me do it in a different ink. Let's say we have a to the power of 3. M is 3 minus 3. So 3 minus 3 is 0. So a to the power of 3 minus 3 means what? It means a to the power of 3 divided by a to the power of 3. Does it make sense? Yes. Well, only if we have a to the power of 3 divided by a to the power of 3, I will write 3 minus 3, correct? See it the other way. Now, if I have a to the power of 3 divided by a to the power of 3, then what do I get? They get cancelled out and I get 1. Correct. Do that mean that a to the power of 0, because 3 minus 3 is 0, is it equal to 1? Well, let's try it once again. This time, we will do it in a different way. Let's say we have 2 times 2 times 2 divided by 2 times 2 times 2. So it is the same number, 8 divided by 8. And what do we get? We get 1. Well, what is 2 times 2 times 2? It is 2 cube divided by 2 cube, right? So if I use my law of dividing powers with the same base, what can I write this as? I can write this as 2 to the power of 3 minus 3, which is 2 to the power of 0. But we know this is equal to 1. So 2 to the power of 0 is 1. Wow. Correct? So what we see is that if we divide same base with same exponents, we get 1. Of course, if I divide, let's say, 16 over 16, we of course get 1, right? 16 could be written as what? 16 could be written as 2 times, let me write 16 as 2 times 4, 2 times 8, 2 times 16. That is 2 to the power of 4. 2 times, 2 times, 2 times. Perfect. This means I could write this as 2 to the power of 4 divided by 2 to the power of 4, which gives me 2 to the power of 4 minus 4, which is 2 to the power of 0, and I know it is 1. So anything to the power of 0 should be 1. That's what zero exponent law is. Anything to the power of 0 is 1, except one thing. What is that one exception? That a cannot be 0. So we write, if a is not equal to 0, then a to the power of 0 is 1. Do you see that rule now? So that's our zero exponent law. Correct? And we tried it so many different ways. We can try with negative number also. Let me do that. So if I have, let's say, minus 5 to the power of 4 divided by minus 5 to the power of 4. Well, they are exactly same number, so this is equal to 1, correct? But if I expand it, or if I write it in this form using my dividing powers with the same base rule, then what do I get? I get minus 5 to the power of 4 minus 4. And that is minus 5 to the power of 0, and it is equal to 1. So if we have 0 in the exponent, then the answer is always 1. So now tell me, solve this problem. What is the answer for this? A cubed times b squared times c to the power of 0. How much this is equal to? Well, anything to the power of 0 is just 1, whatever may be the value of a, b and c. Do you get it? That's very important concept. Okay, I hope you understand it. Thank you.